Hi everyone, today we are going to learn about stoichiometry. It's a funky little word. So I like to start with thinking of chemical equations as recipes. So here's a recipe for a rather sad ham sandwich. With all that leftover Thanksgiving ham, you can make a sandwich. So I ask you, if this is our recipe, 2 breads plus 1 ham equals 1 sandwich, how many sandwiches can be made from 4 pieces of ham? Assume you have infinite bread here. So if you have 4 hams, you can make 4 sandwiches. What if you had 6 pieces of bread? 6 breads. How many sandwiches could you make with that, assuming you have infinite ham? 3 sandwiches, right? Each sandwich uses 2 pieces of bread, as you can see in this picture here. And so, congrats! You just solved your first stoichiometry problem. Right? The ratio between bread and sandwiches is 2 breads for every 1 sandwich. And so, we call this the mole ratio. It's the relationship between different chemicals in a chemical reaction. And so, stoichiometry is the proportional relationship between 2 or more substances during a chemical reaction. Okay, stoichiometry. So we're going to have to use what we call the mole ratio. That's used to convert from one chemical to another. Now, the mole ratio comes from the coefficients. Those are the numbers in front of the molecules in a chemical equation. Okay, so make sure you know where to find those coefficients. Right? That's going to become handy for the mole ratio. Alright, so let's do a problem together. How many moles of water are produced from 12 moles of oxygen? So we're actually going to be doing conversion here. We'll start with our given information always on the left, right? 12 moles of oxygen. And we're given moles of oxygen. So I'm going to put moles of oxygen back on the bottom. And I'm asking for moles of water. So moles of water will go on top. Next, we have to put numbers in the middle here. So where do the numbers come from? They're going to come from the coefficients here. Oops. So I'm looking at 2 moles of water for every 1 mole of oxygen. Right? Just like our recipe, we're just using the numbers here. So then it becomes 12 times 2. The moles of oxygen cancel out, and we'll get 24 moles of water. Okay, so from 12 moles of oxygen, we can get 24 moles of water. So, let's try that again. We'll try a few more examples here. So again, set up your little tea table. It'll be set up for you. 21 moles of oxygen is what we start with. How many moles of iron are needed to react with 21 moles of oxygen? So just like before, I'm going to put moles of oxygen back on the bottom. And here I'm looking for iron. So I'm going to put iron on top. And so now we need to add the numbers. Again, the numbers come from the coefficients found in the chemical equation. So here I'm going to take 4 for iron, put that on top. And for oxygen, it's 3. Okay? So you might be wondering, how do I solve this problem? Well, mathematically, you want to multiply by the numbers on top and then divide by the number on the bottom. So that's going to be 84, 21 times 4, divided by 3. Okay. 7 times 4 is going to be 28 moles of iron. So again, mathematically, I multiply by the number on top and then I divide it by the number on the bottom. Let's try one together, and I'm going to ask you to help me fill in some of these numbers here. So again, we start with 21 moles of oxygen. This time it's asking how many moles of iron oxide, or Fe2O3, are produced from those 21 moles of oxygen. So, just like before, we're going to put moles of oxygen on the bottom. And the chemical that we want is iron oxide. That's going to go on top. So I'm going to ask you, What number do you think goes on top here? Look at the chemical equation on top. What do you think? Well, there's a 2 in front of this iron oxide, so we're going to put a 2 there. What number goes on the bottom here? What do you think? Well, again, we're looking at the coefficients here. There's a 3 in front of that oxygen, so we'll put a 3 there. Next, we just want to solve this mathematically. And how about you try this one out? What do you think the final answer is going to be here? Multiply across and then divide by the bottom number. If you got 14 moles of iron oxide, you are correct. Okay. You can also divide first, so I could do 21 divided by 3, which is 7, and then multiply by 2. Okay, if that's easier for you. Awesome, let's move on. You're gonna have a few practice problems using a different chemical equation. So here are some pointers as you do those problems. Remember that your unknown units, the units that you want, or the chemical you want, goes on top. The chemical that you start with goes on the bottom. Mathematically, you want to multiply by the number on top and then divide by the number on the bottom. Okay? So remember, the mole ratio comes from the coefficients. So look out for those coefficients. Here, the question is not asking for moles, but it's asking for grams. So now we're gonna do a little more, slightly more complicated. It's gonna require one more step. How many grams of water are produced from 2 moles of oxygen? So here I've got my chemical equation. So this is gonna take a few steps. So first, I like to figure out what's the unknown. What am I trying to solve for here? So I want grams of water, and they give me 2 moles of oxygen. Okay, so this is actually going to take 2 steps. First, we have to convert to moles of water before we can get grams of water, right? It's like if I asked you, if you have 2 pieces of bread, how much does your sandwich weigh? Well, you have to make the sandwich first before you can weigh it. So that's what we're doing here. We're going to take those 2 moles of oxygen, and we are going to convert that to moles of water. Again, the numbers simply come from the coefficients. So I'm going to put 2 for water, 1 for oxygen. Mathematically, 2 times 2, I get 4 moles of water. But again, the question's not asking for moles. We are trying to get grams of water. So we're going to have to take that number and do one more conversion. We're going to have to convert that to grams of water. So this is simply multiplying by the molar mass. We've done this before. And so you want to add up 2 hydrogens and 1 oxygen. If we total that up, we get about 18 grams per mole. Remember the molar mass. So now we want to multiply 4 times 18 to get 72 grams of water. Okay, so when you're talking about grams, you're going to have to do 2 conversions to get the answers here. All right, last example problem. How about you help me out with this one? So it says here, how many grams of water are produced when we have 2 moles of propane? So I'm going to start with that, 2 moles of C3H8. I've got a different chemical equation here. And we'll need to look at those coefficients, right? So first step, it says here, convert moles of propane to moles of water. So chemical you want goes on top. I want water. I start with propane. What number should go on top here? What's the coefficient for water? Yeah, 4 is correct. Again, that comes from the chemical equation. What about down here? What number should I put down here? 1 is correct. There's no number in front, so you just assume there's a 1. And so this will cancel out, and we end up with 2 times 4, or 8 moles of water. But again, the question's not asking for moles of water. We're trying to get grams of water. So we got to do one more conversion. And we're going to convert to grams of water. So remember, with molar mass, you can just put 1 mole. Now, what is the molar mass of water? We actually did this in the previous slide. What is the molar mass of water? So if you add everything up correctly, you should be getting 18 grams of H2O. And then we want to do this calculation, 8 times 18. And we get 144 grams of water. And that's our final answer here. All right, make sure you go back and refer to this video and the notes to answer the questions.